Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P006E, indicates a malfunction within the turbocharger power supply circuit. Specifically, this code points to an issue either with the electric throttle control system, ETCS, or the wiring associated with the turbocharger's power delivery mechanism. This error can lead to performance issues, reduced fuel efficiency, and in extreme cases, may prevent the vehicle from running properly. Understanding and addressing this code is crucial for maintaining optimal engine function and overall vehicle performance. Therefore, in this presentation, we will delve deep into the components involved, identifying symptoms, and a systematic troubleshooting approach to rectify any issues associated with DTC P006E. DTC P006E specifically involves the turbocharger power supply circuit, which plays a vital role in engine performance and efficiency. The turbocharger uses exhaust gases to increase the engine's air intake, thereby improving power output. The electric throttle control system, ETCS, is responsible for regulating the airflow into the engine, and it communicates with the powertrain control module, PCM, to ensure seamless operation. The PCM is located under the hood, typically near the engine, and utilizes inputs from various sensors to manage engine functions. If there's a malfunction in this circuit, it can lead to reduced turbocharger performance, ultimately affecting the vehicle's overall power delivery and responsiveness. Identifying the exact location of these components will aid in efficient troubleshooting. A variety of factors can lead to the DTC P006E being triggered. First, a malfunctioning powertrain control module, PCM, could fail to process signals correctly, impacting the turbocharger's functionality. Second, wiring issues such as frayed or broken wires can cause intermittent or complete failures in communication between components. Additionally, blown fuses play a significant role. If the fuse associated with the turbocharger circuit is compromised, it can disrupt power delivery to the turbocharger, leading to this error code. It's important to methodically explore these potential causes, as they are critical to resolving the malfunction indicated by DTC P006E. When dealing with DTC P006E, several symptoms may manifest, indicating a deeper issue within the vehicle's turbocharging system. Decreased engine performance is often the most noticeable symptom, as the vehicle may struggle to accelerate effectively. Another common symptom is poor acceleration response. Drivers may feel as if the car is lagging during takeoff or when attempting to gain speed. Furthermore, if DTC P006E is active, it may be accompanied by other trouble codes related to the electric throttle control system, ETCS, such as P1658 and P1659. These signs should prompt immediate attention and diagnostic evaluation to prevent further complications. The first step in troubleshooting DTC P006E is to verify the problem. Begin by turning the vehicle into the on mode without starting the engine. This enables diagnostic tools to access the car's computer systems. Next, use the Honda Diagnostic System, HDS, to clear the DTC. This action helps reset the system and can sometimes resolve any temporary issues causing the error code. After clearing the DTC, turn the vehicle off and then switch it back to the on mode. Finally, check for any pending or confirmed DTCs again using the HDS. If P006E is still indicated, it confirms that further investigation is warranted. While its absence may suggest intermittent issues best remedied by inspecting connections and terminals. In the second step, check for pending or confirmed DTCs once more using the HDS. This confirmation helps ascertain whether DTC P006E persists or if any other DTCs such as P1658 or P1659 are present. These codes are related to the electric throttle control system, ETCS, and indicate its control relay malfunctions. If either P00658 or P00659 is indicated, move on to the specific troubleshooting steps for those codes. However, if no related DTCs are present, it may be time to proceed with additional checks and diagnostics, allowing for a more comprehensive examination of the turbocharger's power supply circuit. The third troubleshooting step involves checking the vehicle's fuses, specifically fuse number A38. Before doing so, ensure the vehicle is turned off to avoid any electrical shorts or damage. Remove the cover of the fuse box and locate fuse A38. This fuse is crucial for the operation of the turbocharger power supply circuit. If the fuse is intact, then you can move on to the next step. However, if the fuse is blown, it warrants immediate attention, as it indicates a possible short circuit or wire-related issue that could be contributing to the DTC P006E. This step is critical, as it allows you to isolate fuse-related faults from other potential electrical problems. During the fourth troubleshooting step, the objective is to check for open wires in the circuit. Begin by jumping the SCS service control switch line with the HDS and wait for more than a minute. Then, disconnect the necessary connectors, the PCM connector A and the relay circuit board connector C. This disconnection allows for a safer and more accurate continuity check. With the vehicle still in off mode, check for continuity between test points. Test point 1 is the female terminal number 16 on connector C, and test point 2 is the number 3 terminal on connector A. If continuity exists, the VB ACTA FI sub-Riley out wire is functioning properly, suggesting that the issue lies elsewhere, possibly with the relay circuit board or PCM. If no continuity is found, this indicates an open wire that must be repaired. The final troubleshooting step focuses on identifying any shorted wires within the VB ACT line. Start by removing the blown fuse A38 to prevent further electrical damage. Then, jump the SCS line with the HDS, allowing a brief waiting period for accurate diagnostics. Ensure the PCM connector A is disconnected before proceeding to check for continuity. Specifically, check between test point 1, which is terminal number 3 of the PCM connector A, and test point 2, which connects to body ground. If continuity is present, this indicates a short in the VB ACT wire needing repair. Also, remember to replace the blown A38 fuse in the process. If no continuity is found, replacing the fuse and rechecking the circuit is recommended. If the new fuse blows again, the underhood fuse relay box may need replacement. Upon completing the troubleshooting process for DTC P006E, it is essential to conduct a final verification of the repairs made. Begin by confirming that all repairs, whether it involved replacing wires, fuses, or circuit-related components, have been successfully completed. After ensuring that everything is in place and functioning, take the vehicle out for a test drive. Assess the vehicle's performance in various driving conditions to ensure that the issue has been rectified. Following this, use the Honda Diagnostic System, HDS, to recheck for any remaining or new DTCs. This thorough approach is crucial, as it not only verifies that the issue has been resolved, but also helps prevent any recurrence of the DTC in the future. Preventive maintenance is an essential aspect of vehicle ownership, particularly regarding issues like DTC P006E. Regular inspections of the turbocharger system and associated wiring are vital to catch potential issues early on. Keeping electrical connections clean and secure can help maintain good communication between components, thereby increasing reliability. Furthermore, proactively replacing aging or worn fuses ensures that all systems remain protected from electrical faults. Additionally, ensuring that the PCM software is updated can prevent future miscommunications and malfunctions. Routine checks and maintenance will not only prolong the lifespan of components, but also enhance the vehicle's overall performance. In conclusion, understanding the implications of DTC P006E and the turbocharger power supply circuit malfunction is critical for any Honda Accord owner. Follow a systematic troubleshooting approach to accurately pinpoint and resolve any issues. Through diligent diagnostics and repair, one can restore optimal function for better performance and efficiency. In addition, embracing a culture of preventive maintenance can significantly reduce the likelihood of future occurrences related to this DTC. Ultimately, proactive measures lead to longer vehicle life, enhanced performance, and increased driver satisfaction. Always remember that addressing these codes promptly ensures your car remains reliable and enjoyable to drive. Please like and subscribe to the channel. See you next time.